Alright, welcome back, Honors Pre-Calculus, SPV Math with Monte. Now, pre-calculus students, week 32. Only 6 weeks of school left. Hopefully you enjoyed last week, Mother's Day. In a couple weeks we got Memorial Day, and we're wrapping up school. If you need any of the old videos, don't forget you can just go to our pre-calculus teams page and you'll see our stream channel. If that doesn't work for you, that's okay, because we just want to go to the internet, find our digital tools, find our Clever, find our Blackboard. When you find Blackboard, you scroll around until you find Honors Pre-Calculus, and in the announcement page, each week I just keep piling it on, piling it on, piling it on. Alright? And you can go back in there. Alright, now, cheat sheets. We're getting ready for calculus. Alright? I think we skip everything up to calculus because in the live classes next week they will actually try to spend the next 30 days on Unit 9, Introduction to Calculus. Now here's my opinion. We're trying to get you ready. If you're taking Honors Pre-Calc, you're looking for college credit, you're looking to be an engineer, you're looking to be a doctor, you're looking to be a scientist, you're looking for high-level, rigorous math. Calculus is where it's at. And we don't really use these in calculus, all right? Statistics, if you're going to be going into number theory and those sorts of things, and analysis and sales, you will get this actual unit in college. Okay, so we're going to spend the rest of the time on videos with Introduction to Calculus. Here's Monte's opinion. Okay, click on Calculus. We have limits and motion. What is calculus? The analysis of rate of change, the slope of the line, and what does it mean as we accelerate or decelerate? What's the velocity at each of those points, okay, as we come to a stop, or as we approach cruising speed, what happens to the slope of the line? So you're going to see average, rate of change, slope, equations, tangent lines, and it's a new vocabulary. Then we get to limits. What is the limit as we approach, as we flatten off, okay? And you're going to see these terms over and over and over. Basic derivatives. This is where we want to get to as we come to school next year and enter calculus. We want to be able to recognize these terms, okay? And how the curve of the function, a parabola, the derivative, the slope of the line, the velocity at an instant in time. Okay? Alright. We need these. And then the second derivative, what is a derivative? Okay? So this is where we want to get to so that at least we've seen all these terms when we come to school next fall. What does that mean for you, the student? I would suggest the following. We want to watch every one of these videos, and we want to take notes. Notes are the key to success in calculus. We need these note sheets. So I've sent you folks the actual cheat sheet from bar charts for Introduction to Calculus. You should find these on there, but I want you to take notes on each of these. So just for the fun of it, we click on a video, and we got this gentleman, and he's going to talk to us about...
We'll talk about one-sided limits. Here's a function, g of x equals, and it's piecewise defined, x plus 8 for x less than negative 4, and x squared minus 1 for x greater than or equal to negative 4. Describe its behavior as x approaches negative 4. Well, at negative 4, that's where the two pieces are kind of joined together, and so it may behave differently depending on what side of negative 4 we're on. So let's try approaching negative 4 from the left. Negative 5 is to the left of
There we go. Sorry. Okay. So now, terminology. Okay. I'm hoping that you folks are willing to watch each video. And I think he said negative 4. 1, 2, 3, 4. At negative 4, something is happening. Okay? And the term that I want you to think about is as we approach the function from -4. So as x approaches -4 from the left. Then he talked about as we approach -4 from the right. Okay, and I'm not sure what those functions were, but he said something like x plus 4, so it's growing. And then what was the other side? X squared minus 1. X squared minus 1. X squared minus 1. X squared minus 1 is a shape like this. Okay, so from the other side we have this kind of a shape, right? So from this side, okay, looking at it from the right as we approach, it looks like the numbers are gaining, right? They're getting bigger. But from this side, they're getting bigger, but in a different way. What happens as we approach from one side and from the other side? This is a terminology I want you to start to think about. Okay, so that's the first video. Second video, graphical approach.
I want to talk about one-sided limits. Here's a function, g of x equals, and it's piecewise defined, x plus 8, moving to the right, from -5, -4.1, -4.09, and you can see that these values seem to be getting closer and closer to 15. It's -4. Whenever the two ends
Okay, so it looks like the same video.
This theorem states right here. Limit as x approaches a of f of x equals. I want to talk about one's. Now, in a positive direction.
Okay,
Now,
so he's talking about the same problem. Looks like the same video to me. Okay. All right. So now let's go to the next one. Tangent lines. Okay. Again, a terminology, a way of talking. All right. So for the next week or two, watch these 3 videos. Motion and area. Motion and area. Okay, different function. What happens? Okay, we start to analyze the details as we approach a certain point. Okay, all right, and again, slope of the line, the rise over the run.
And we get 2010, 2010.
Okay.
You can see it.
All right. So again, I think the best thing we can do the next couple of weeks is just watch the videos. And here's why. Because all of a sudden, there's no other assignments been assigned. Okay, we just did log cosines. Now we're going to go to limits, motion, this tangent. So you see how the very first assignment is going to talk about this tangent line. Until you've watched these videos and hear the vocabulary, okay, the tangent. The point of the graph corresponds to x equals 0, 0, 5. Now we want to talk about these tangent lines. What happens at that particular point in time? Okay, so I think the best thing we could do, you can go ahead and start these problems, but that's not as important as watching every video. There's not very many videos. Okay, that was 9A. Then we get to 9B. Again, we're only going to have, 2 videos. And then we've got average rate of change. Okay, this is the actual tangent line. Okay, and you're like, wow, there's only 8 videos. Okay, now when we go to the actual assignments, they have their own videos in a lot of them. Okay, so I think we spend more time on video watching, okay, than we do the actual working, because it's a vocabulary. Okay, in calculus, it's a vocabulary. In the cheat sheet I sent you, whoa, there's a lot of vocabulary, and we want to talk about math in a different way. We're analyzing the details. Okay, so as a car accelerates, each point in time is the velocity. Okay, so as I go from 0 to 60 on the freeway, at each instant in time is what is called the velocity. Okay, so I think that'd be a great way to start. We've got 6 weeks to finish, 8 videos, and 8 videos, 1, 2, 3, 4, 5 assignments. Okay, so you can see there's some heavy lifting in here, but it's all up here in trying to take all the math that we've ever done and relate it from an engineering standpoint. Have a great week. Enjoy the weather. It's starting to warm up, and don't stress volume. Okay? Monte from Honors PreCalculus signing off.